A gemstone banned from export, another removed from open trade. One exists, but rarely enters the market at all. Not because they are illegal objects, because control changed around them. At different moments, governments, institutions, and supply chains quietly reshaped who could access certain stones. No public countdown, no obvious warning, just fewer legal pathways between discovery and ownership. Starting with a blue crystal whose entire global supply depends on a single narrow valley near Mount Kilimanjaro. Ranked 10th, Tanzanite, the gem controlled by geography. Most gemstones become rare because nature makes them difficult to find. Tanzanite is different. Its rarity does not come from depth or harsh mining conditions or extreme geological instability. It comes from something far more unusual: location. Every known Tanzanite crystal ever discovered traces back to a remarkably small area near the foothills of Mount Kilimanjaro in northern Tanzania. Not a continent, not a geological belt stretching across multiple countries. A single mining corridor, only a few kilometers wide. A narrow zone where a very specific combination of heat, pressure, and trace elements aligned under conditions scientists still struggle to fully replicate. If this geological event had occurred just a few kilometers in another direction, Tanzanite might not exist at all. And when an entire global gemstone category depends on one location, control becomes inevitable. Over time, Tanzanian authorities recognized something unusual about Tanzanite. It was not simply a gemstone. It was a globally desired resource whose supply could never diversify. Unlike diamonds, which are mined across multiple continents, or sapphires, which appear in numerous geological environments, Tanzanite had no backup source, no secondary deposits waiting to stabilize the market. Only one origin. This created a structural imbalance between global demand and geographic availability. And when a resource becomes structurally irreplaceable, governments begin to pay attention. Policies began shaping how rough stones could leave the country. Export structures evolved. Cutting incentives shifted, not to eliminate ownership, but to influence where value was created, where expertise developed, where economic benefit remained concentrated. Because when the entire world depends on one narrow geological corridor, that corridor becomes more than a mining site. It becomes leverage. Tanzanite quietly demonstrates a pattern seen across multiple resource categories. Control does not always begin with prohibition. Sometimes it begins with location. Because when supply cannot move, policy does. And in rare cases like this, geology itself becomes the first form of restriction. A reminder that before any sanction is written, nature may have already limited who can truly access the source, which raises an uncomfortable question that continues throughout this list. When rarity becomes geographically locked, who really controls ownership? And how often does the market notice only after the restriction already exists? Ranked 9th, Jadeite, the stone that became a national asset. Some gemstones are valued for brilliance. Others are valued for rarity. Jadeite reached a different level entirely. It became inseparable from identity. For centuries, the finest jadeite has been associated not simply with ornament, but with continuity, status, and generational wealth preservation across parts of Asia. Imperial courts, elite families, and high-level collectors did not treat jade as decoration. It functioned more like a store of cultural legitimacy. What made this dynamic more complex is the geological reality behind the material. Despite jade's long global history, the highest-grade jadeite, the type displaying saturated green translucency, often referred to in the trade as imperial quality, has historically been concentrated in northern Myanmar, particularly within the Apakan mining region, a location where geology, tectonic pressure, and mineral chemistry combined under very specific conditions over millions of years. When a gemstone becomes deeply embedded in both cultural symbolism and concentrated geographic origin, the stone begins to occupy a different category, not purely commercial, not purely aesthetic, strategic. Over time, regulatory structures began shaping how jadeite could leave the country in rough form. Policies periodically encouraged local processing and valuation before export. The reasoning was not framed around restricting collectors, but around ensuring that the highest value transformation stages did not occur entirely outside the country of origin. Because when raw material exits too early in the supply chain, much of the economic benefit leaves with it. Jadeite demonstrated how a gemstone can evolve into something closer to a national resource. Its value was no longer driven only by clarity, color, or translucency. It was influenced by perception of continuity. Control over distribution began to intersect with control over narrative. Who determines authenticity? Who defines grading standards? Who participates in primary allocation? Over time, these layers created a market environment where access to top material did not operate like a typical open commodity system. Supply still circulated, ownership still existed, but the pathway between mine and collector became increasingly structured, more selective, more filtered. Jadeite reveals a subtle shift that occurs when a gemstone moves beyond mineral classification and becomes associated with heritage itself. At that point, regulation does not always present itself as restriction. Sometimes it presents itself as stewardship, because when a material becomes tied to identity, perception, and long-term cultural continuity, its movement across borders is rarely treated as routine, which introduces a different form of limitation, one not driven by scarcity alone, but by significance. And once significance enters the equation, markets begin operating under rules that are not always visible at first glance. The stone itself does not change, but the meaning attached to it does, and meaning, over time, can influence access just as strongly as geology. Ranked 8th, Kashmir sapphire, the supply that disappeared into history. There are moments in geology that behave almost like accidents, events so specific, so unlikely in their formation conditions, that once they pass, they do not repeat. Kashmir sapphire belongs to one of those moments. In the late 19th century, high in the remote Zanskar range of the Himalayas, landslides exposed pockets of corundum crystals, displaying a type of blue unlike anything widely seen before. Not the bright commercial blue of modern heated stones, and not the dark inky saturation sometimes found in basalt-hosted deposits. These sapphires displayed a soft, velvety optical texture caused by microscopic inclusions that scattered light in a way that reduced harsh reflection while preserving saturation. The visual effect created a depth collectors often describe as calm rather than brilliant, a color that did not appear aggressive under light, a blue that seemed internally stable. For a brief geological window, production from this deposit entered circulation. Then the window closed. Mining conditions at extreme altitude proved difficult to sustain. Combined with political instability, logistical limitations, and environmental constraints, extraction gradually slowed until meaningful supply effectively stopped. Unlike many gemstone categories where new discoveries stabilize markets, Kashmir sapphire never experienced a true secondary deposit capable of replicating its characteristic optical appearance. Other sapphires exist in abundance across Sri Lanka, Madagascar, Myanmar, Thailand, and Australia. But the precise combination of silk inclusions, trace element chemistry, and geological formation conditions found in Kashmir did not scale geographically. Over time, access became less about mining rights and more about historical timing. Most stones now associated with Kashmir origin entered the market decades ago, circulating through auctions, estates, and legacy collections. As availability decreased, verification standards increased. Documentation became essential. Origin reports became critical. Not because ownership was prohibited, but because new supply was no longer replenishing the category. In markets influenced by finite origin events, control does not always appear in the form of regulation. Sometimes it appears as absence. When a deposit becomes inaccessible due to geography, climate, or political complexity, distribution shifts towards secondary circulation rather than primary extraction. Kashmir sapphire represents a form of limitation shaped not by modern policy structures, but by the intersection of environment, altitude, and history. A geological occurrence that behaved more like a closed chapter than an ongoing resource, which introduces a different type of constraint explored throughout this list. When no additional material can realistically enter the pipeline, access begins depending less on discovery and more on timing. Because in rare cases like this, the restriction is not imposed after the fact. It is built into the timeline of the deposit itself. A reminder that some forms of limitation are not announced. They simply become visible gradually as availability narrows and the possibility of replacement disappears. Ranked 7th. Red beryl. Extraction limited by fragile geology. In most gemstone deposits, scale is the objective. Larger mining operations, deeper excavation, expanded production capacity, all designed to increase recovery rates and stabilize supply. Red beryl follows the opposite pattern. Its geological formation occurs under extremely narrow conditions, involving high-temperature volcanic activity interacting with beryllium-bearing gases in silica-rich rhyolite environments. The chemical window required to produce the red coloration, primarily linked to trace amounts of manganese, is so specific that only a handful of locations on Earth have ever produced crystals of meaningful size. Even within those locations, most crystals form small, fractured, or included. Transparent specimens suitable for faceting remain exceptionally uncommon. The primary commercial source in Utah sits within a geological environment where extraction intensity must be balanced carefully against environmental stability. Unlike deep kimberlite pipes or widespread alluvial deposits, the host rock structures associated with red beryl are relatively delicate, meaning aggressive mining methods risk destroying more crystals than they recover. Over time, regulatory frameworks and land use oversight influenced how much material could realistically be extracted without destabilizing the surrounding geological structure. Production never scaled significantly. Instead, supply developed slowly and inconsistently. Red beryl demonstrates how limitation can emerge from the physical sensitivity of the deposit itself. Because when a gemstone forms in environments where mechanical disturbance reduces recovery efficiency, extraction becomes less about expansion and more about precision. Mining shifts from industrial scale toward controlled removal. Each recovered crystal representing the result of navigating geological constraints rather than overcoming them. Unlike gemstones, whose scarcity results primarily from depth or remote geography, red beryl introduces a quieter constraint: fragility. Not fragility of the gemstone once cut, but fragility of the environment that creates it. In deposits like this, increasing output too aggressively can permanently reduce long-term yield, meaning restraint becomes part of resource management strategy. Over decades, this has produced a supply profile characterized by intermittent availability rather than continuous market flow. Collectors rarely encounter large red beryl stones, not because interest is low, but because formation probability remains extremely limited even before mining begins. And when geology offers only a narrow margin for successful extraction, policy frameworks often align with preservation rather than acceleration. Because once the host environment is disrupted beyond recovery, future production may not return. Red beryl reveals an important pattern within restricted resource dynamics. Not all limitations originate from ownership rules or trade barriers. Some originate from the physical sensitivity of the Earth systems that create the material in the first place. In these cases, constraint becomes embedded in the structure of the deposit itself. Extraction is possible, but expansion is not always practical, which introduces a subtle form of restriction that does not rely on enforcement, only on geological boundaries that cannot easily be widened. Ranked 6th, Paraiba tourmaline, when chemistry becomes a strategic discovery. A laboratory result rarely changes the trajectory of an entire gemstone category overnight, yet that is precisely what happened when trace element analysis revealed the presence of copper within a group of tourmaline crystals discovered in the Brazilian state of Paraiba during the late 1980s. Copper is not unusual in industrial materials. It is fundamental to electrical conductivity, telecommunications infrastructure, and countless technological systems. But within tourmaline, copper behaves differently. It alters the way light interacts with the crystal lattice, producing an unusually vivid optical intensity, often described as neon-like, that appears to glow even under low lighting conditions. This optical phenomenon did more than introduce a new color range. It introduced a new classification challenge. Paraiba tourmaline did not behave like traditional blue or green tourmaline varieties already familiar to the gem trade. Its saturation levels appeared unusually high relative to trace element concentration, and its internal light transmission properties produced a visual effect that seemed disproportionate to the size of the stone. Once the geological explanation became widely understood, demand accelerated rapidly. Unlike diamond or sapphire deposits distributed across multiple continents, the original Brazilian material originated from a geographically restricted pegmatite system, where extraction conditions proved technically demanding and production volumes remained limited. As awareness expanded, attention shifted from simple valuation toward resource longevity. Small deposits with high international demand can experience rapid depletion if extraction intensity scales too quickly. In such environments, oversight mechanisms often evolve in parallel with market visibility. Licensing structures, monitoring processes, and local regulatory frameworks begin shaping how quickly rough material enters global circulation, not necessarily to prevent ownership, but to prevent exhaustion. Paraiba tourmaline illustrates how a gemstone can move beyond aesthetic classification and enter discussions about resource pacing. Because when a discovery introduces a material displaying properties not widely replicated in nature, its supply timeline becomes part of its long-term value structure. Overproduction risks collapsing the rarity narrative that supports collector confidence. Underproduction risks limiting economic benefit for producing regions. Balancing these pressures often requires measured extraction rather than aggressive expansion. As new copper-bearing tourmaline deposits later appeared in Mozambique and Nigeria, market terminology adapted, but the original Brazilian material retained distinct historical significance due to its discovery context and initial scarcity profile. This created layered market behavior, similar chemistry across different localities, but not identical perception. Paraiba tourmaline demonstrates how certain gemstones begin influencing decisions, not only within jewelry markets, but within resource management discussions typically associated with technologically relevant materials. Because when chemistry produces an optical effect perceived as fundamentally different from established categories, the discovery itself becomes something that must be managed carefully, not restricted outright, but rarely allowed to expand without observation, a reminder that scientific understanding can sometimes increase control rather than reduce it, especially when that understanding reveals how limited the original conditions truly were. Ranked fifth, Grandidierite. When discovery itself triggers oversight. New gemstone discoveries rarely remain quiet for long, particularly when the material displays a color range and transparency combination previously considered improbable within its mineral class. Grandidierite was first identified in southern Madagascar in the early 20th century, but for decades it remained primarily a mineralogical curiosity rather than a faceted gemstone seen in high-end collections. Most known specimens displayed opaque or heavily included structures, limiting their use in jewelry. That changed when transparent material began appearing in small quantities. Suddenly, a mineral once considered academically interesting entered the commercial gemstone conversation. What made Grandidierite unusual was not only its rarity, but the difficulty of predicting where gem-quality crystals might form within its host environment. Deposits did not follow broad, easily mapped geological belts. Instead, occurrences appeared sporadically, often requiring extensive exploration with uncertain outcomes. When transparent crystals emerged, their supply proved inconsistent and highly sensitive to extraction intensity. Small deposits with unpredictable yield profiles can disappear rapidly under unregulated mining pressure, particularly in regions where artisanal mining operations expand quickly following international attention. In response, oversight mechanisms often begin to appear around newly recognized rare materials, not always as outright prohibitions, but as attempts to monitor extraction pace, regulate export channels, or introduce licensing requirements designed to prevent sudden depletion. Because once a deposit-producing gem-quality material is exhausted prematurely, the probability of rediscovery remains extremely low. Grandidierite demonstrates how awareness alone can influence supply behavior. Before recognition, a mineral may exist in relative obscurity. After recognition, it can experience rapid demand escalation disproportionate to its geological abundance. This creates tension between short-term extraction incentives and long-term resource sustainability, particularly when local economies benefit from responsible pacing rather than rapid exhaustion. In gemstone markets, the moment a material transitions from mineral specimen to collector gemstone often represents the most volatile period in its life cycle. Information spreads quickly, exploration activity increases, supply channels adapt in real time. Regulatory responses sometimes follow in order to maintain balance between economic opportunity and geological preservation. Grandidierite's emergence into gem quality visibility illustrates how discovery itself can function as a trigger for structural change, not because the stone becomes restricted in the conventional sense, but because its rarity becomes measurable for the first time. And once rarity becomes measurable, extraction decisions rarely remain informal, especially when the entire global supply may depend on only a few small production zones vulnerable to rapid depletion. In such conditions, the most effective form of control is not necessarily limitation of ownership, but limitation of speed. Because when the pace of extraction exceeds the pace of understanding, future availability may disappear before the material's true significance is fully studied. Grandidierite represents a stage in gemstone evolution where recognition introduces responsibility, and responsibility often brings oversight, not imposed suddenly, but gradually as awareness of scarcity becomes impossible to ignore. Ranked fourth, Burmese ruby. When reputation reshapes access. Few gemstones have experienced a transformation in perception as dramatic as ruby from Myanmar, historically known as Burma. For centuries, stones from the Mogok Valley established a standard for red coloration that other deposits struggled to match. The combination of chromium-rich corundum and low iron content produced a saturation often described in the trade as pigeon blood red, a color balance that appeared vivid without becoming dark, maintaining internal luminosity even in subdued lighting. These characteristics place Burmese ruby among the most sought-after colored gemstones in high jewelry history. But the forces influencing access to this material did not originate in geology alone. Over time, political developments surrounding Myanmar altered how goods originating from the region were perceived within international markets. Regulatory environments evolved, and in certain jurisdictions, trade restrictions influenced how rubies from this origin could legally circulate. Not because the gemstone itself had changed, but because the global framework surrounding its country of origin had shifted. Gemstones rarely exist in isolation from the environments in which they are extracted. They move through supply chains shaped by logistics, certification processes, trade agreements, and international policy structures. When geopolitical conditions influence trade relationships, materials associated with those regions can experience indirect limitations on distribution pathways. Documentation requirements increase. Verification processes become more stringent. Auction houses, dealers, and collectors adapt to ensure compliance with evolving regulations. In some periods, stones from particular origins encountered reduced market visibility not due to declining demand, but due to increased complexity surrounding lawful trade. This created a layered perception effect. On one level, Burmese ruby retained its reputation as one of the most historically significant colored gemstones. On another, its presence within certain markets became more conditional. Availability did not disappear completely, but access pathways required more careful navigation. Burmese ruby illustrates how gemstones can become influenced by reputational frameworks extending beyond mineral classification. Origin begins shaping legal context. Legal context begins shaping market confidence. Market confidence begins shaping circulation patterns. Over time, the gemstone's narrative expands beyond color, clarity, and carat weight. It begins including questions of traceability, documentation, and historical chain of custody. Collectors increasingly rely on origin reports and compliance assurances, not simply for valuation purposes, but for regulatory alignment. Because in internationally traded goods, perception of legitimacy can influence liquidity just as strongly as rarity. Ruby from Myanmar demonstrates how a gemstone's accessibility can be influenced indirectly through evolving policy environments rather than direct ownership restrictions. The stone remains physically unchanged, yet the pathways connecting mine to market may narrow, adapt, or temporarily shift direction. A reminder that in rare cases, limitations arise not from geological scarcity, but from the broader context in which the gemstone exists. And once context becomes part of valuation, access itself becomes more selective, even when demand remains constant. Ranked third, Benitoite, when a gemstone becomes a protected scientific reference. Certain minerals transition from commercial objects into scientific benchmarks. Benitoite represents one of the clearest examples of this shift. Discovered in San Benito County, California, this rare barium titanium silicate quickly attracted attention not only for its optical beauty, but for its crystallographic structure and geological rarity. Its intense blue fluorescence under ultraviolet light and distinctive triangular crystal habit placed it into a category that interested mineralogists as much as collectors. Unlike gemstone varieties found across multiple continents, gem-quality benitoite emerged from a remarkably localized geological environment associated with hydrothermally altered serpentinite deposits, a formation pathway involving a precise interaction of barium, titanium, silica, and low-temperature hydrothermal fluids, a combination not widely reproduced in other regions. Over time, the primary commercial mine ceased large-scale production, and access to the locality became increasingly limited. The area gained recognition not only as a source of collectible gemstones, but as an important reference site for mineralogical research and geological documentation. When a deposit contributes significant information about how rare minerals form, preserving geological context becomes part of the value. Scientific institutions rely on intact locality data to understand formation conditions, trace element pathways, and crystallization sequences. Removing material without controlled documentation risks erasing information that cannot be reconstructed later. Because unlike mass-distributed minerals, benitoite exists within a narrow geological framework where each specimen may provide additional data about formation history. As the supply of newly recovered crystals slowed, circulation shifted primarily toward existing specimens already in collections. Market availability did not disappear entirely, but the pathway connecting discovery to ownership became increasingly dependent on historical recovery rather than ongoing production. Benitoite illustrates how a gemstone can move beyond decorative use and enter a classification closer to scientific reference material. In such cases, preservation of the locality itself becomes part of long-term knowledge continuity. When geological environments are limited in scale and difficult to replicate, protecting contextual integrity becomes as important as protecting the crystals. Because once the host environment is significantly altered, future research opportunities diminish. This introduces a form of limitation that does not originate from demand suppression or trade regulation. Instead, it emerges from recognition that certain locations hold information exceeding immediate commercial value. Benitoite's rarity therefore operates on multiple levels: mineralogical uniqueness, geographic concentration, and scientific relevance, each layer contributing to why access to newly extracted material became increasingly uncommon over time. A reminder that some gemstones are valued not only for how they appear, but for what they help explain. And when a mineral contributes meaningfully to understanding geological processes, preserving its origin environment can influence how frequently new specimens are allowed to enter circulation. In such cases, limitation becomes part of conservation, not imposed to restrict appreciation, but to ensure that knowledge associated with the material remains available for future study. Because once geological context disappears, so does the ability to fully interpret how the gemstone came to exist in the first place. Ranked second, Musgravite. When availability exists mostly on paper, statistics rarely convey emotional impact. A mineral can be described as rare, exceptionally rare, even extraordinarily rare. But numbers alone do not always communicate what rarity actually means in practical terms. Musgravite changes that perception. First identified in the Musgrave Ranges of Australia in 1967, this member of the taphite family remained largely unknown outside mineralogical circles for decades, not because interest was low, but because confirmed specimens were almost non-existent. Early documentation referenced only a handful of known crystals worldwide. In some periods, fewer examples of musgravite were recorded than certain famous artworks. Availability did not follow traditional market behavior. There was no steady mining output, no predictable annual production, no consistent appearance in dealer inventories. Instead, new specimens appeared sporadically, often separated by years, sometimes discovered accidentally during examination of other minerals, sometimes identified only after advanced gemological testing distinguished them from visually similar materials. In practical terms, ownership opportunities did not depend primarily on price. They depended on timing, being present at the exact moment a specimen entered circulation. And even then, availability rarely extended beyond a very small network of specialized collectors and institutions. Musgravite demonstrates a condition where supply is not actively restricted by policy, yet access remains functionally limited. Because when the number of known gem-quality stones remains extremely low, distribution does not operate through traditional retail pathways. It operates through awareness, through relationships, through proximity to discovery channels. In markets where production is measurable in individual crystals rather than kilograms, availability behaves differently. Visibility becomes intermittent, ownership becomes statistical. Many collectors may never encounter an opportunity to acquire a verified specimen during their entire collecting lifetime. Not because access is prohibited, but because probability remains exceptionally low. This creates a form of limitation independent of regulation, a constraint embedded in discovery frequency itself. Musgravite introduces an important distinction within the concept of restricted resources. Some materials are difficult to own not because they are forbidden, but because they rarely appear. When appearance intervals extend across years or decades, participation becomes limited to those positioned close to primary circulation points, which often include research institutions, advanced collectors, and specialized dealers with the capacity to authenticate and preserve extremely uncommon mineral specimens. The result is a gemstone category where theoretical availability exists, but practical accessibility remains narrow, not enforced by written policy, enforced by rarity itself. Because when global supply can be measured in dozens rather than thousands, ownership becomes less about acquisition strategy and more about whether opportunity appears at all. A reminder that some of the strongest restrictions are not announced. They are implied by numbers so small that the market never fully stabilizes around them. And when stability never forms, access remains permanently uncertain. In first place, Painite, the gemstone that rewrote the meaning of scarcity. Discovery does not always guarantee availability. In rare cases, discovery simply confirms how little of something exists. Painite represents one of the most extreme examples of this phenomenon in modern gemology. First identified in Myanmar during the 1950s by British mineralogist Arthur C.D. Payne, the material initially appeared so unusual that it was not immediately classified as a new mineral species. Its chemical composition, containing calcium, zirconium, boron, aluminum, and oxygen arranged within a highly uncommon crystal structure, did not match known reference profiles at the time. Verification required extended laboratory analysis before recognition as a distinct mineral species was confirmed. For decades after its identification, the number of known crystals remained extraordinarily small. So small that for a significant period, fewer specimens were documented than most collectors would encounter of any other faceted gemstone category. Painite became widely referenced in gemological literature as one of the rarest minerals ever identified. Not rare within a jewelry context, rare within a planetary context. Unlike gemstones whose scarcity results from controlled distribution or limited mining rights, Painite demonstrated a deeper constraint: formation improbability. Its crystal chemistry requires an uncommon alignment of elements rarely concentrated together in the same geological environment. Even when the required elements are present, the crystallization conditions must remain stable long enough for lattice formation to complete without structural disruption. Such conditions appear to occur extremely infrequently. Later discoveries increased the number of known specimens modestly, yet supply remained limited compared to mainstream gemstone categories. Production did not scale in the way markets typically expect. Even after identification became more widespread, new material entered circulation slowly and irregularly. Painite therefore illustrates a type of limitation that precedes regulation entirely. When a material exists in quantities so small that market infrastructure cannot fully develop around it, accessibility becomes inherently constrained. Dealers cannot maintain consistent inventory. Auction frequency remains low. Pricing frameworks evolve slowly due to limited transaction history. Collectors operate with incomplete comparative data. Ownership opportunities appear episodically rather than continuously. In such conditions, participation depends less on purchasing power and more on situational timing. Because when specimens surface infrequently, acquisition windows may close quickly and remain closed for extended periods. Painite demonstrates how the concept of restriction can originate at the atomic level. Before geography influences supply, before policy influences distribution, before markets establish valuation benchmarks, scarcity already exists within the crystal's formation probability. A gemstone so structurally uncommon that its presence in collections often reflects decades of geological coincidence rather than systematic extraction, which reframes the broader theme explored throughout this list. Limitations on ownership do not always begin with external control. Sometimes they originate within the fundamental constraints of mineral formation itself. Painite does not require regulatory restriction to remain inaccessible to most observers. Its rarity performs that function naturally, because when the number of opportunities to encounter a gemstone remains extremely low, ownership becomes less a matter of decision and more a matter of circumstance. A final reminder that in certain corners of gemology, the most powerful form of limitation is not imposed by institutions, but written into the structure of the material long before it is ever discovered. Some limitations come from rarity, others come from decisions made around the rarity. The stones did not change, access did. Which raises a final question. In the future, will the rarest gemstones be defined by geology or by who controls the pathway between discovery and ownership? Because sometimes the most important shift happens quietly, long before the market notices.